Okay, we are live. Hello, everybody. Welcome to this Verbling class. My name's Teacher Amy, if you haven't seen me before. And this class is the second on what I've really just realised is my mystery morning. We've just been talking about the Malaysian Airlines crash, and now we're going to be talking about parallel universes. So if this is the kind of thing that interests you, come along in and join us. We're going to be reading something about quantum physics. So if you're interested in science, or perhaps you already know about physics, maybe you're a physicist, then come along in and help us, because I'm certainly not an expert, but I do find it very fascinating. It's a great article, so we'll practice our reading and we'll talk about what we read together. This is part of one of my classes where we're trying to learn a bit more advanced vocabulary in certain areas. So if you're interested in increasing your vocabulary in the area of science, it might be worthwhile attending and joining us. However, you might be just interested in the topic and want to chat about it and practice your speaking and reading skills, so that's also very welcome. So, excuse me. Just while we're waiting for everybody to get here, I'll briefly share a couple of pages with you in the chat boxes, just in case you haven't been with us on Verbling before and you're not sure what's going on. There's several resources that you can use to help you find out a little bit more and keep in touch with everybody. Considering that we're all in different parts of the world, it's a really well-connected place to be, and I think one of the best ways to learn a language. I'm horribly biased, of course, but do check out our teacher pages and our Facebook pages. You can see the links to mine in the chat boxes if you would like to get in touch with us, find out more, attend more classes, or perhaps join a one-on-one tutoring session. Then you can visit the teacher pages or our Facebook page to connect up and find out more. So those pages are there for you. Now, let's see who we've got today to talk about this topic. Our theme today is quantum physics and particularly parallel universes. So we're going to just have a quick hi, see who we've got today, and find out if we have anyone who knows anything about this already. If not, just your general opinion. Do you think there are really parallel universes? So there are lots of great books that I personally have read which discuss this idea, and I think it's an interesting one, but I'm not totally convinced yet. Perhaps at the end of this lesson I will be, you never know. Alright, let's see. Who have we got? We're going to say hello to the lovely Ali. Welcome back, Ali.
Hi again.
Alright, so Ali, we've just seen you in the other class. Your brain is full of mystery, I'm sure. You're ready to talk about parallel universes.
Yeah, maybe.
What do you think? Do you think they're a load of rubbish, or do you think, parallel universes, interesting possibility?
Yeah, it's a possibility. You know, we live in a universe. There are a lot of galaxies, different galaxies. The world or our galaxy is only one of them. Maybe thousands of galaxies, and I think there are some parallel universe or maybe life on another planet or on another galaxy. Why not?
Okay, so excuse me, you're open to the possibility that definitely something could exist that we don't know about yet.
Yeah.
Okay, thank you, Ali. All right, who else do we have? Marco, hello.
Hello.
How are you?
Fine, thank you.
You sound like you've got a very strong opinion to share with me. It was just in the way that you said hello.
I think that if physics say that parallel,
if physics says,
sure that they exist, but I think that they are very different from what we think about them in, for example, what we have seen in movies. That means parallel universes with people like us, where there are another Marco or another Amy there with similar lives. I think that very often physics and the science theory are very different from what we think about it, because
All right.
they think in another way, at another level.
Okay, so
And
very interesting.
just to make the things simple, they try to tell us in a simple way, and we understand in a wrong way because it's too simple.
Okay, very interesting point, Marco. So you think that there is such a thing possibly as the parallel universe, but the public's interpretation of it is probably completely wrong thanks to oversimplification and possibly Hollywood.
Yeah, something like that.
Okay, great, thank you. Who do we have here? Mohammed, have I met you before? Hello, Mohammed. Hello, are you there? No? All right, we'll come back to you. Maybe he zapped into a parallel universe. Mustafa, hello.
Hello, teacher.
Welcome back.
Thank you.
Okay, Mustafa, I'm ready. Tell me what you think about parallel universes.
I don't have a lot of idea about like parallel universe, but it's come to my mind like there's like a parallel universe. Like it would be the same people there, like same human or other kind of things, or
Aliens?
yeah, aliens, something like that. So it's really like a lot of puzzles, and we don't know a lot of things. But you know what? Like the universe is so large and huge, and maybe the physicists, as you said, like they know better than us. And each day we know more information about this universe because it's so huge and so large. So we cannot say, we cannot judge. I cannot judge in my opinion.
All right, so you think keep an open mind because there's a lot that we don't know yet.
Yeah, keep an open mind. Yeah, that's the correct answer.
Okay, very interesting. We've got a wide range of ideas so far. Excellent. So let's say hello to Martin. How are you, Martin?
Fine, thank you. Well,
Nice
parallel
to see
universe.
you again.
Yeah, that's you. Parallel universes, I think it's a sort of a model. And to think
Okay.
about this idea is not the same as saying that it exists. So I rather say it's a model which can get people to understand what quantum mechanics is about.
Mhm.
Quantum mechanics is so difficult to understand, and just to help understanding, you can make lots of models, and that is one of the models. But the very idea of the parallel universes is that you cannot communicate with another universe.
Mhm.
So it's the same of, I can imagine, say, the flying spaghetti monster. I can imagine it is, but it's not the same as saying that it exists.
Okay, very
Some
interesting.
people imagine a god, but you can never communicate with the god, and is that the same as it is not existing? And I would rather say, if you cannot in any way get in touch or get signals from the other kind of universe, then I would rather say it does not exist, but it's a nice idea which might help you to understand what's going on.
Okay, thank you, Martin. That's a very fascinating view.
A model which can get you to sort of grasp what's going on in a way, but you shall not. It's not the same as they exist.
All right, so in a way similar almost to what Marco was saying. It's sort of like an idea to help us understand something because of the complicated nature of quantum physics, but it in itself maybe doesn't actually, it's not real. Kind of right?
Yeah.
So I just want to introduce you a little bit more, Martin, because I met you the other day and found out that you actually taught maths and physics, right? So you maybe know a bit more than the rest of us. Did you study quantum physics at all in your career?
I did physics in the 60s, 1962 to 67, and physics is only my minor subject. And of course, I've taught physics in Sixth Form College,
Yep.
but quantum mechanics, I have just had a single course, and I read about a bit about it. But so I am in no way an expert in these matters. I would say.
Very humble of you, Martin. I think you perhaps might be slightly more of an expert than us, though. So it's very good to have you here today. We might ask you some questions later. All right,
Right.
welcome. All right, Paul, off you go. Tell us what you think.
Okay, so it's kind of a complicated matter, as we all mentioned before, and I don't have a strong opinion about it, but I've read some books, sci-fi ones, and I picked one suggestion up from one of those, and here it is. So there are a lot of people in our universe, and we just make decisions all the time. Yeah, and every decision which we make creates a different universe. I think you understand. And so the number of the universes is simply innumerable, and it's like a collection of soap bubbles. And this amount continues constantly to grow. So that's my version.
Okay, interesting. Do you know, when you were speaking, actually, you reminded me of something. When I was younger, I used to read these books, and they were called Choose Your Own Adventure books. I don't know whether you guys have ever read them. But you read a bit of the story.
Yes, I did.
Yeah.
We had like a page of text, events, and at the bottom, we had a couple of choices. Okay. Yes.
Exactly.
It's
something like
really
that?
good explanation. Yes, something like that. Yes.
Okay.
Exactly.
Except much, much bigger, right? There's much more than
of
two
course.
options.
Like innumerable
Okay.
amount of possibilities.
Yeah. And I don't know about you, but once I'd finished my adventure, I used to go back and see what would have happened if I'd chosen all of the other options. So I ended up reading the entire book, and it was very confusing, which is obviously not what you can do with real life.
I would do a different thing. I did like little pieces of paper, and I wrote numbers on those. So I investigated all possibilities. So I cheated.
You cheated.
Yeah.
Disgusting.
Yes, there was no need to go back to the beginning. I just continued from the previous choice.
So yeah, so you
Clever
read all of
me.
the choices. And some of them were, you're dead. So then you had to go
Yes.
back to the beginning.
Yes.
Yeah.
There were not so many of good ones.
Yeah, I agree. All right, well, there you go. If you've never read one of the Choose Your Own Adventure books, you're missing out, so go and get one. Hello to Anna Carolina.
Hi, teacher. Nice to meet you.
Hello, welcome. We're just talking about parallel universes. Do I call you Anna or Carolina or Anna Carolina?
Whatever. Which one do you prefer? You
Probably
can call.
Anna.
Okay, it's okay.
Is that all right? All right, wonderful, because it's easier for me if there's only one name per person. All right, so, excuse me, guys. I'm sorry, I've got a bit of a cough. What we'll do is we'll share my screen. I'll share my screen. We're going to start reading, and we're going to find out a little bit about what this guy, Philip Ball, thinks about quantum physics and parallel universes. So if we just... we'll just read this little bit at the side, first of all, so we can find out who Philip Ball is. If you want to load this up, the links are there for you in the chat box. I'll just repaste it for Anna. There you go. Otherwise, you can just see what's going on my screen. So I'm going to ask Ali, if you could just read here, please, Ali. Philip Ball, who is he?
Okay. Philip Ball is a British science writer whose work appears in Nature, New Scientist, and Prospect, among others. His latest book is Invisible: The Dangerous Allure of the Unseen.
Okay, so if you find this...
2014.
Yes, thank you. Sorry, Ali, didn't mean to interrupt you there. If you find this article interesting, you want to find out more, you can check out this guy, Philip Ball. He's written a book. He also contributes to some journals. So we now know who is the writer, who the writer is, and we're going to start reading. Anna, could you read just this little part here for us, the little kind of caption
No.
sort of thing.
Okay, nobody knows what happens inside quantum experiments. So, why are some so keen to believe in parallel universes?
Excellent. Okay, I think it's a nice thing to remember while we're reading this. The fact that we don't actually know very much about this topic so far. It's kind of still, even though we've been, I don't know how long quantum physics has been around, but it seems like we're still researching it and we don't know very much. So we're all sort of speculating, some people with a better knowledge base than others. So let's continue reading. Don't forget, guys, one of the purposes of this class is to learn a little bit of vocab related to science and also to practice your reading. So don't rush, take your time, and we'll pause after each paragraph or so that we can discuss what we're reading and make sure everybody's following. So, Marco, off you go in July.
In July 2011, participants at the conference on the placid shore of Lake Traunsee in Austria were polled on what they thought the meeting was about. You might imagine that this question would have been settled in advance, but since the broad theme was quantum theory, perhaps a degree of uncertainty was to be expected. The title of the conference was Quantum Physics and the Nature of Reality. The poll, completed by 33 of the participants, physicists, mathematicians, and philosophers, posed a range of unresolved questions about the relationship between those two things, one of which was, what is your favorite interpretation of quantum mechanics?
Great, thank you, beautiful Marco. Just two words I want to check over. They weren't pronounced incorrectly, but I just want to sort of consolidate. So this one here is physicists.
Physicists.
Yes. And the other one is posed.
Posed.
Good. I want to point out that to pose a question is a very nice way of, it's a great collocation. Those two words go really nicely together. It's a lovely thing to say. So to pose a question is quite a nice way of to say to ask a question or put a question out there to be answered by anybody. Anyone have any questions about other vocabulary?
Teacher, at a conference on the Placid shore, Placid, what's the place or Placid? I don't know.
Placid. What does placid mean? Anyone know?
Sort of nice, soft, calm place.
Calm, peaceful, or quiet.
Yeah, absolutely. I think calm is probably the one that we all agree on. Peaceful, calm, not rough. So a nice calm lake. Sounds quite idyllic. Any other questions? No? Okay. Let me ask Paul. I think it's an interesting opening paragraph myself. Can you tell us what have we found out in very few words? Just a quick summary. What's this
Okay,
about?
no problem. And the main idea is that 33 participating physicists were kind of confused because when they arrived at the conference, only then they found out what is going to take place and what is going to be discussed. And
Yes.
it's pretty engaging.
Thank you, Paul. It's not quite that they found out. They did not find out what actually happened.
Okay. They were asked a question.
Exactly. They were asked, what is this conference that you are attending about, right? So there wasn't already a program. They were actually asked what they thought it was going to be. So we're going to find out next what happens. So Mustafa, if you could please read from the Word.
Okay. So, can you hear me?
Yes.
Yeah, the word favorite. The word favorite. It's
From
very
here. Yep.
Complete? I have to complete the chat?
Yes,
Or
keep
what?
going, keep going. Isn't science?
Yeah. Isn't science supposed to be decided by experiments and observation, free from personal preferences? But experience in quantum physics have been obstinately silent on what it means. All we can do is develop hunches, intuitions, and yes, cherished ideas of these. The survey offered no fewer than 11 to choose from, as well as other and none.
Okay, thank you very much, Mustafa. Wonderful reading. Any questions about vocabulary? We'll talk about the meaning in a second.
Okay,
Yeah,
what's hunches? Tell us, please.
A hunch. What's a hunch? Anyone know?
I guess.
Yes. It's
something that
almost a guess, Martin. It's slightly different to a guess.
Yeah, a vague idea of what's going on.
Yeah, it's exactly. It's sort of like what you... Can you hear me okay, Martin?
Yes, yes.
Sorry, I think I missed that. I saw that you were talking, but I couldn't hear you.
Yeah, I said it is something you can get a vague idea of a guess of what's going on, so you can just work on further on it just by having this slight guess or help or push.
Exactly.
About.
Yeah, exactly right. So it's like if you have a hunch about something, it's what you possibly think. It's like what you feel might be true, and then you can use that to direct your research, possibly. Anna's given a nice one, a guess based on intuition. Yeah, that's a really lovely description. Any other questions?
Cherished.
Teacher. Yeah.
Cherished. What is cherished?
Like the idea, love the idea.
Yeah, something that's loved or liked. Exactly. Perfect. Thank you, Martin. Okay, Martin, I would like to ask you a question, actually, just about this paragraph and this question that comes before it. So the question that they asked the participants is, what is your favorite interpretation of quantum mechanics, which suggests there isn't actually a real definition. Could you tell us what actually, in your opinion, is quantum mechanics? If you were asked this question, what would you tell us?
Well, it is a theory in physics where you can explain what is going on in the micro world when it's only the smallest thing you have, atoms and particles, and you will never electrons. You will never see these wonderful, interesting happen in normal life. I think there is a book called Mr. Thompson in Dream World or something like that, where, no, not that one, but where you have tried to see what would happen if the quantum effects were in fact real in our world, so we would always see what's going on. And it is so strange, really, so nobody can understand what's going on. If somebody says, I now understand quantum mechanics completely, then you'll know he doesn't understand it really.
Okay.
So, and that's therefore there are more than 11 different ways of trying to understand what it is. So
yeah.
you get some experiments, and you have a theory which can explain it, but that's not the same as that you understand it, because the models will be so complicated. So you have to have these things with parallel universes and so on if you really should have a model worthwhile explaining what it's all about.
All right, beautiful. Thank you. That really makes it clear. So nobody understands it really. So this is why they've asked, what do you think? What is your theory? And there were 11 choices plus other or none. I wonder if anybody answered other or none. All right, so let's carry on reading. And Martin, could you take this next part for us, the most popular?
The most popular, supported by 42% of the very small sample, was basically the view put forward by Niels Bohr, Werner Heisenberg, and their colleagues in the early days of quantum theory. Today it is known as the Copenhagen interpretation. More on that below. You might not recognize most of the other alternatives, such as quantum Bayesianism, relational quantum mechanics, and objective collapse, which is not, as you might suppose, just saying, what the hell. Maybe you haven't heard the Copenhagen interpretation either, but in third place, 18% was the many worlds interpretation, MWI, and I suspect you do know something about that, since the MWI is the one with all the glamour and publicity. It tells us that we have multiple selves living other lives in other universes, quite possibly doing all the things that we dream of but will never achieve or never dare. Who could resist such an idea?
Thank you, Martin. All right, very fitting. Actually, one of your names is Niels, right? And the Copenhagen theory, well, you're from Denmark, so there you go. Very exciting having you in class. Anyone have any questions? So we've got a couple of quite tricky names of things, but apart from that, any questions about the English?
Would you try to pronounce the Bayesianism?
Yes, I can. I would go for Bayesianism, perhaps. Bayesianism?
Yeah.
But then again, you know, I have no idea, so it could be wrong.
Yeah.
So everyone following? So we've got a few. We're given a few of the 11 answers. And the one that we're focusing on is the many worlds interpretation, which is what we're going to find out a little bit more about. And this is, I guess, what we were speaking about at the beginning of class, the kind of Hollywood thing, where we all have different lives and we're doing the different things with the same bodies in other places or something along those lines. All right, thank you very much, Martin. Paul, your turn. Yet resist.
Okay. Okay, yet resist we should. We should resist not just because MWI is unlikely to be true, or even because, since no one knows how to test it, the idea is perhaps not truly scientific at all. Those are valid criticisms, but the main reason we should hold out is that it is incoherent, both philosophically and logically. There could be no better contender for Wolfgang Pauli's famous put down. It is not even wrong.
Keep going.
And yet it attracts both publicity and extraordinarily confident endorsement. Why? To understand that, we need to see why, more than 100 years after quantum theory was first conceived, experts are still gathering to debate what it means.
Thank you. Very lovely reading from you, Paul. Okay, interesting. Let's just check that we are all following the vocabulary. Anyone want to ask anything? No? I just want to mention a couple of kind of phrasal verbs that we should just quickly focus on. So what does it mean to hold out?
Maybe stay away from it.
Yeah, okay. Stay away from it. Any other suggestions?
Keep holding. I don't know.
Keep what? Sorry.
Hold it. Keep hold it. No, I don't know.
Yes. Okay, that's slightly closer. It's a bit of a strange one. It actually means to not give up. Actually, so not give up. And well, just
like to endure.
To endure, sort of, yes, exactly. Almost like to not give up quite yet, because there's other things to think about before we get rid of the idea completely. And then put down, what's a put down?
I think what meant there is rule.
A rule?
Like rule, yes.
Not exactly. A put down isn't really a rule. Does anyone else know what it is?
An axiom or something like that.
Killing an animal, maybe.
Ah, yes. To put an animal down is to kill an animal. Yeah, in a nice way, right? But actually, a put down is something slightly different. Okay, Anne is the closest. Yes, Marco? Yeah.
A statement, like a statement. Put
A
down.
statement, yes. What kind of statement, though? It's a very particular kind of statement.
I don't know.
No, it's like a negative statement. If you put somebody down, it means that you're saying something negative about them. And this is what Wolfgang Pauli said. This theory is so ridiculous. It's not even wrong. It can't even be proved to be completely wrong. It's so bad. It's outside of the realm of being wrong. So that's what he means.
Yes, and the funny thing that it might sound so ridiculous that it may be right. Okay.
Good point, Paul. And here we are discussing quantum physics. Congratulations. Okay, I just want to welcome Dom, who's just joined us. Hello, Dom.
Oh, hi, Amy.
All right. I won't explain too much. I'll just let you get used to what we're talking about in class today. It's a bit beyond all of us, I think. So we'll let you just join in slowly. And I'll get Ali to read a little bit more so we can carry on. So Ali, despite...
There are some vocabulary I want to ask.
Oh, okay, sorry, Ali. Yeah, go ahead.
One is incoherent.
Incoherent. Okay, what does incoherent mean?
Coherent is to be connected, and then incoherent is not connected.
Yes, exactly. Not connected, or maybe slightly more like not very clear.
Yes, not right. I don't think maybe something like that.
Yeah, I think both of you are right there, Dom and Martin. If we connect your two definitions, it's something that's not connected and not right at the same time. So it doesn't follow a very logical path. You can't connect up the points and so that it makes sense. Okay?
Yes, it's like mismatch.
Yeah, it's like a mismatch. That's a nice way of putting it. Yeah.
Okay. Contender. What's that?
Which one? Oh, a contender.
Better
Okay, what's a contender?
Contest is you are having a contest between people, and the participants are called contenders.
Exactly. Something or somebody that's in a competition with another person or thing. Correct. Any other questions, Ali?
Component.
Sorry, which one?
Like opponent. Or...
Opponent. Yes, exactly. Opponent.
Oh, okay.
All right. Are we all clear, everybody? Yeah.
Yeah.
Let's go. Ali, off you go. Despite its shaky foundations.
Okay. Despite its shaky foundations, quantum mechanics is extraordinarily successful. In fact, you'd be hard-pushed to find a more successful scientific theory. It can predict all kinds of phenomena with amazing precision, from the colors of grass and sky to the transparency of glass, the way enzymes work, and how the sun shines.
Thank you. Well done. A couple of words just to check over. This is pronounced phenomena.
Phenomena.
Yep. We'll talk about that in a moment. This one's enzymes.
Enzymes.
Yes. Okay. Phenomena is one of those words that comes from Latin and has a weird singular and plural. So the singular of phenomena is, anyone know?
Something, well, phenomena, lighting is a physical phenomena, for example.
Mm-hmm. Absolutely. So how would you just define phenomena, Martin?
Or say, something you can watch and hear
Yeah,
in the world around you. Something
Yep.
is happening, and you say, now this phenomena has just
yes,
happened.
exactly. It's quite hard to explain, actually, isn't it? Even though
Yeah.
you feel like you know what it is. Yeah, something like maybe something that exists, something that is happening, something that you can experience, to do with science or that kind of thing. Nice try. Well done, Martin. I find it hard too. Anyone else want to ask anything?
No.
No? All right, let's continue. And we'll find out why it's successful. Anna, could you read from This Is, please?
This is because it's largely a technique, a set of procedures for calculating what properties substances ought to have based on positions and energies of their constituent subatomic particles. The calculations are hard. For anything more complicated than a hydrogen atom, it's necessary to make simplifications and approximations. But we can do that very reliable. And so the vast majority of physicists, chemists, and engineers who use quantum theory today don't need to go to conferences on the nature of reality. They can do their job perfectly well if, in the words of the physicist David, I don't know how to pronounce his name.
Don't
They
worry.
just shut up and calculate.
Thank you, well done. Just a few words to go over. So first of all, this one here is procedures.
Procedures.
Well done. And then we have, if I can find it, reliably.
Oh, sorry. Reliably.
No worries. So it's almost like reliable, but this is an adverb, okay? And then this one here, physicists.
Physicists.
Yes, very important, that word today. Quite tricky. All right, have we got questions? We've got a couple of quite tricky words in here. Nobody? Or are we too embarrassed to ask?
What is constituent subatomic?
Particles. All right, let's look at, first of all, subatomic particles. And Martin was talking about these before. Martin, could you just repeat, what is a subatomic particle?
That is the particle which will create an atom. That can be a neutron and a proton. That will be the building material of an atom or an atom. To say atom or atom? Atom. The building material for atoms will be neutrons and protons. And again, the protons and neutrons are built by something even smaller. And then you really have to go into quantum physics. And I have only vague ideas of what's going on there, I must admit.
All right. Thank you, Martin. So just a little word about pronunciation. Actually, with those particular words, neutron, proton, electron, we actually emphasize the on at the end of the word a little bit more.
Yeah, neutron, atom.
Why? Yeah, exactly. Yeah. So that's what subatomic particles are, the tiny things that make up the atoms. And constituent, what does constituent mean? Anybody? Anna, you've given us a nice definition.
Okay. Parts of the atoms are the constituent of the atom.
Yeah, exactly. It's like the parts. Very good. The parts. Any other questions? No? We're okay? All right, I'm going to ask Dom. We haven't heard from you for a few minutes. Dom, could you just take this paragraph here and in your own words just say what's it saying?
Oh, okay. I have to describe this paragraph?
Yeah, just a little summary, not too long.
Ah, okay. because it's a dangerous technique. It's a procedure for calculating that. Oh, sorry, I'm not very focused.
No problem.
And okay. It talks about the atoms and the constitution of of the subatomic. I don't know. The subatomic particles.
Yeah.
And yeah, and as we said before, it's about the parts of obviously the materia. I don't know if it's correct. And
Yes.
and so and okay, for it more complicated.
What does it say about the nature of the quantum physics? How complicated it is? How do you get around that?
Okay. Okay. Now I'm a little bit more free. I think it's really complicated because the rules that that regulate that kind of I don't know, that part of science are very it's very difficult to define the rules about that science because the way that particles behave or I don't know respect the normal way where I don't know, atomic particles acting it's unknown because they sometimes acting in really strange ways. I read many times ago about the experiment to the particles that acting in the way where or which the observer look at these particles.
Okay. Yeah, absolutely.
Yes.
That's a very good point,
Yes.
Dom. Thank you. It was quite tricky to summarize, but you got the point of it.
Yes.
That it's very
Yes.
complicated, but we don't need
Yes.
to understand every part of it in order to be able to make calculations.
Yes.
And
Another thing. Sorry. Another thing is that more tiny are the particles, more tiny for atoms. So these particles are very unstable. Not difficult to study about that because it's not. Some particles are very difficult to observe.
okay, good point.
Sometimes.
Yeah, because they're so tiny, which is kind of what Martin was saying before. Yes, you've brought up some very unusual points, which we're going to expand on in the next paragraph. So thank you for that, Dom. All right, Paul, could you read for us? It is true, though.
Okay, it is true though that the equations seem to insist on some strange things. They imply that that very small entities such as atoms and subatomic particles can be in several places at the same time. A single electron can seem to pass through two holes at once, interfering with its own motion as if it was a wave. What's more, we can't know everything about a particle at the same time. Heisenberg's uncertainty principle forbids such perfect knowledge. And two particles can seem to affect one another instantly across immense tracts of space, in apparent but not actual violation of Albert Einstein's theory of special relativity.
And Paul, could you just read this part here too?
Okay, before we look, there are only probabilities. When we open the box, they give away to a single actuality.
Great, thank you. So this is bringing together quite a few points. Just one pronunciation. This is electron.
Okay, electron. Good.
Yeah, so the emphasis is on the electron.
Okay, got it.
Excellent. Thank you, Paul. All right, so questions about vocab or possibly about sentences. Does everyone understand this paragraph?
Okay, I think I understood it because I've read something about that. So, and the point is that the particle can be either a particle or a wave or both things at the same time, and we can't know the speed of that particle and perfect location of it at the same time. We can know either one thing or another, and not both at the same time.
Okay.
So that's the summary.
Yep. I think it's...
Another...
Yeah, go ahead.
Another way to see the Heisenberg principle is that the phenomena is composed by the phenomena itself and the observer. That means that when I'm the observer, observe the phenomena in this case changes. It's very difficult to understand, but I've studied it at my high school when I studied physics, and if I see when I see the subatomic phenomena, I change the phenomena in the action of seeing.
Okay.
That's why it's impossible to understand where is in a very specific instant of the time, because if I see it, I change the phenomena. It's like there is something in the Buddhism that is similar in such a way that they say the Buddhists, I have heard them in China and also in India, they say that if a tree fall in a forest and there are no person there to hear the noise, are we sure that the noise exists? Because if the noise is something, I see a similarity between this concept and the physics concept and the philosophic concept. Because if to hear a sound is a phenomena that needs to have something that causes the sound, like the tree falling in the wood, but also somebody that hear the sound.
Okay, well explained, Marco.
A little bit complex, but...
It is very complex, but you did explain that very well. Does anyone want to comment or add anything to that? Or respond?
I'll just say the example, if you shall measure a temperature with a thermometer, if the thermometer is very large and what you are measuring is very small, then the temperature after you have measured it has changed. If say that is 100 degrees in temperature, and you are putting it in a small glass of wine, then the wine will be heated by the thermometer after you have measured the temperature.
Ah, interesting. I like that one, Martin. That's quite interesting. Yeah, it's a good way of showing how the thing that's measuring can affect the thing that's being measured, right?
Yeah.
Okay, so it's quite a difficult concept, because I think when we learn traditional science, we are totally separate. We're just observing. We're not connected in any way to the experiment. But actually, quantum physics is saying we are connected to the experiment.
Yes.
If you look at this quote here, I suppose it's quite nice to go back to the example of the Choose Your Own Adventure book. And it shows how there's a slight difference, because if you think about the book, all the options are already written down, and when you open the book, you see the option that you choose. So what it's saying here is, before we actually look at the options, there aren't any options, there's just probabilities, and then when we focus on it, that becomes the choice, so we're somehow affecting it. It's very kind of interesting and confusing at the same time. So let's continue to read. Anyone want to volunteer to read?
Me.
Okay, thank you, Dom. Quantum scientists.
Okay. Quantum scientists, for the most part, just accept such things. They are no longer especially controversial. What really divides opinion is the fact that the theory seems to do away with the idea of objective reality that we can study from the outside. Such a notion has been central to science from its beginnings, and yet quantum mechanics insists that we can make a measurement without influencing what we measure. This isn't a problem of acute sensitivity. It's more fundamental than that. I'll explain.
All right, thank you, Dom.
Sorry.
No, we'll stop there because we're about to open a can of worms. Are you guys ready for this? Do you want to continue and hear the explanation? We might start it, we might not have time to finish it, but I think it is fascinating. Before we start, does anyone have any questions about this section here? No?
No, it's as I said, and sorry, and Marco said after me, it's the way where observer look at the experiment, influence the experiment. I think it's the main topics of
exactly. So it's sort of just explain, well, just what we've been speaking about. So now he's going to tell us a little bit more about it. Let's see if we can cope with this next paragraph, which is quite interesting. Any other reading volunteers?
I could do it.
Please.
Okay. I think that was. Anna sounds like she's more desperate than you, Martin. I'll come to you next.
Yeah,
okay.
yeah, okay.
All right, Anna. Off you go.
Thank you. The most widely used form of quantum methods, devised by Erwin Schrödinger in the 1920s, involves an abstract object called a wave function. This wave function expresses all that can be known about a quantum object, such as a particle. But it doesn't tell you what properties the object has. Instead, it enumerates all the possible properties it could have, along with their relative probabilities. Which of these possibilities is real? Is an electron here or there? We can find out by looking. But here's the thing. Quantum mechanics seems to be telling us that the very act of looking, of making a measurement, forces the universe to make that decision at random. Before we look, there are only probabilities. When we open the box, those probabilities give way to a single, determinate actuality, something conventionally called collapse of the wave function. But wave function collapse isn't actually part of the theory. It has to be put in by hand, as it were. That is rightly considered to be most unsatisfactory. Sorry.
Thank you, Anna. Well done, because that was a tricky paragraph. What I'm going to do is actually ask Martin. Martin, could you help us a little bit with that? Could you explain to us in your own way what this idea of a wave function is?
Well, it is a function which in a way should tell everything we know about, say, a particle. It could be an electron or a proton. You have a special differential equation, a partial differential equation, the Schrödinger equation, which the wave function must be a solution to. And the wave function can be used to calculate the probability that the particle is at a special place in the world. And in fact, the electron, say, can be anywhere but the probability of it is in certain places are very little, and in other places the probability will be much higher. And the wave function, that is a way of nowadays to explain what's going on when you are dealing with small particles like electrons and protons. And
okay. Thank you.
I think, and I must say, I have to leave you now. I've been very happy being here, so I have to be something else.
All right. Thank you, Martin. Thank you for your help. See you later.
See you.
All right, so guys, we're getting really in depth now to this whole quantum physics explanation, and you're doing extremely well. I must say I'm impressed for a group of, well, now we're definitely a group of non-scientists. I might consider putting another class as in quantum physics part 2, because I think we're only just getting down into the deep aspects of it. So we're going to have to finish in a second. How frustrating is that? But thank you for all your reading. I just want to mention before the end of class, is there something, okay, just tell me one thing that you found interesting from this lesson, something that we read or something that we talked about. So Marco, you're first.
Yes, it's interesting to me in this lesson that I refreshed what I've studied at the high school and at the university, but in a different way. That means without math, but just in a way more
with English.
divulgative. Yes, in English, of course, because I studied in Italian. But you know, mathematics is a universal language. You can so to study in a language or in another, it's almost the same. But it's interesting to see how a journalist or whatever can explain it in trying to explain a very complex theory in an easy way, even though I think that it's not so easy to understand.
Thank you, Marco. Good point. I'll ask Ali. What do you think, Ali? Did you find anything particularly interesting today?
I don't know. It was very difficult for me to understand because I don't know about quantum mechanics or physics. I just learned some vocabularies.
That's great! Well, that's excellent. For those of you who found it a bit crazy and want to read more, I will share that we've got the link there. I might do the same as I did with the last class and open up a little discussion on Facebook. And thank you very much for all of you for participating, because you were pretty brave. I know it was a tough topic. There was some great vocabulary, but I hope you've learned something and maybe, I don't know, opened your mind to the world of possibilities. So I hope you all have a really lovely evening. If I don't see you again soon, then have a great week, and I hope to see you in another class. See you later.
Okay, bye-bye.
Bye.
With us on Verbling before and you're not sure what's going on, there's several resources that you can use to help you find out a little bit more and keep in touch with everybody. Considering that we're all in different parts of the world, it's a really well-connected place to be, and I think one of the best ways to learn a language. I'm horribly biased, of course, but do check out our teacher pages and our Facebook pages. You can see the links to mine in the chat boxes if you would like to get in touch with us, find out more, attend more classes, or perhaps join a one-on-one tutoring session. Then you can visit the teacher pages or our Facebook page to connect up and find out more. So those pages are there for you. Now, let's see who we've got today to talk about this topic. Our theme today is quantum physics and particularly parallel universes. So we're going to just have a quick hi, see who we've got today, and find out if we have anyone who knows anything about this already. If not, just your general opinion. Do you think there are really parallel universes? So there are lots of great books that I personally have read which discuss this idea. Excuse me. You're open to the possibility that definitely something could exist that we don't know about yet.
Yeah.
Okay, thank you, Ali. All right, who else do we have? Marco, hello.
Hello.
How are you?
Fine, thank you.
You sound like you've got a very strong opinion to share with me. It was just in the way that you said hello.
I think that if physics say that parallel,
If physics says,
sure that they exist, but I think that they are very different from what we think about them in, for example, what we have seen in movies. That means parallel universes with the people like us, where there are another Marco or another Amy there with similar lives. I think that very often physics and the science theory are very different from what we think about it, because they think in another way, at another level.
Okay, so very
just to make the things simple, they try to tell us in a simple way, and we understand in a wrong way because it's too simple.
Okay, very interesting point, Marco. So you think that there is such a thing possibly as the parallel universe, but the public's interpretation of it is probably completely wrong thanks to oversimplification and possibly Hollywood.
Yeah, something like that.
Okay, great, thank you. Who do we have here? Mohammed, have I met you before? Hello, Mohammed. Hello, are you there? No? All right, we'll come back to you. Maybe he zapped into a parallel universe. Mustafa, hello.
Hello, teacher.
Welcome back.
Thank you.
Okay, Mustafa, I'm ready. Tell me what you think about parallel universes.
I don't have a lot of idea about like parallel universe, but it's come.
And I think it's an interesting one, but I'm not totally convinced yet. Perhaps at the end of this lesson I will be. You never know. All right, let's see. Who have we got? We're going to say hello to the lovely Ali. Welcome back, Ali.
Hi again.
All right, so Ali, we've just seen you in the other class. Your brain is full of mystery, I'm sure. You're ready to talk about parallel universes.
yeah, maybe.
What do you think? Do you think they're a load of rubbish, or do you think parallel universes, interesting possibility?
Yeah, it's a possibility. You know, we live in a universe. There are a lot of galaxies, different galaxies. The world or our galaxy is only one of them. Maybe thousands of galaxies. And I think there are some parallel universe or maybe life on another planet or on another galaxy. Why not?
Okay, so okay, we are live. Hello, everybody. Welcome to this Verbling class. My name's Teacher Amy, if you haven't seen me before. And this class is the second on what I've really just realized is my mystery morning. We've just been talking about the Malaysian Airlines crash, and now we're going to be talking about parallel universes. So if this is the kind of thing that interests you, come along in and join us. We're going to be reading something about quantum physics. So if you're interested in science, or perhaps you already know about physics, maybe you're a physicist, then come along in and help us, because I'm certainly not an expert, but I do find it very fascinating. It's a great article, so we'll practice our reading and we'll talk about what we read together. This is part of one of my classes where we're trying to learn a bit more advanced vocabulary in certain areas. So if you're interested in increasing your vocabulary in the area of science, it might be worthwhile attending and joining us. However, you might be just interested in the topic and want to chat about it and practice your speaking and reading skills, so that's also very welcome. So, excuse me. Just while we're waiting for everybody to get here, I'll briefly share a couple of pages with you in the chat boxes, just in case you haven't been